This lesson is on graphing linear inequalities. When we're graphing an inequality, we're talking about an equation that has a greater than or less than sign in it. So we're not just talking about one line of points, we're actually talking about a much larger group of points. When we graph a linear inequality, we get it into the same format that we do with a line. We want it to be in slope-intercept form. So you'll see our y is by itself on the left, and then we have the slope in front of the x and our y-intercept. So we're going to go ahead and plot that. We graph the y-intercept first, so we're going to plot -2 on the y-axis. And our slope is 2/3, so we're going to rise 2 and run 3. Since it's positive, we're going to run to the right, and we can make a couple of points if we'd like, even some this direction. And normally if we were graphing a line, we would just connect those points. But since this is a greater than sign, if you have greater than or less than, you're going to have a dashed line instead of a solid line. So we're going to grab a line. We're going to go ahead and graph it. First, it's going to look like a solid line. Then we're going to have to change it here in a second using the program. And then we'll just change that. We'll go to Properties. And we'll tell it that we want it to be a dashed line. So that's the first difference, is that we sometimes have a solid line or a dashed line. The second difference is we need to shade in order to find all of the points that fit this. We want all of the points that y is greater than 2/3 times x minus 2. So we're either going to shade above the line or below the line. When you're deciding, you want to choose a test point. 0, 0 is a great test point unless it falls on your line. If it falls on your line, you're going to have to choose a different point. But otherwise, 0, 0 is great. And what we do is we plug in a 0 for y and a 0 for x. So this becomes 0 is greater than 2/3 times 0 minus 2. So 0 is greater than 0 minus 2. Is 0 greater than -2? It is. So this is a true statement. If it's a true statement, then you shade to on the direction where that point is. It's above the line, so we're going to shade all the points above the line. So I'm going to get a highlighter here and shade all the points. All these points in the area that I'm shading work in that inequality right here. They all work for that. At any point I could pick this point. If I plugged it in, it would work and make that a true statement. So here's one of our major differences. If we have greater than or less than, that's when we get the dashed line. If it's less than or equal to or greater than or equal to, we get a solid line. The dashed line happens because those points are not solutions to the inequality. If I plugged in those ordered pairs, they would not work. You'd get a statement something like, maybe 3 is greater than 3, and we know that that's not true. The solid line means those points are solutions to the inequality, so they are going to work. If you've got something like that, but it said 3 is greater than or equal to 3, that would be true because we know that 3 is equal to 3. Let's graph a system. Here we want to graph the system y is greater than -x plus 4, and 2x minus y is greater than -2. The first one is ready to graph. We have the y-intercept and the slope. The y-intercept is 4, so 1, 2, 3, 4. We have a slope of -1, so that's going to look like this. It's a solid line because it's greater than or equal to, so we're going to just go ahead and draw a solid line there. And then we need to determine where to shade. If we plug in the point 0, 0, we would get 0 is greater than or equal to a -0, which is 0 plus 4. Is 0 greater than 4? And we know that that's not a true statement. So we shade on the opposite side of the line from where 0, 0 is. We are not going to shade below this time. We're going to shade above because this is opposite the side of where 0, 0 is. I'm going to erase that I use that as a test point so I don't get confused. Then for the second equation, you'll notice it's not in slope-intercept form, so we're going to have to manipulate the equation a little bit. Subtract 2x from both sides. We get -y is greater than -2x minus 2. We don't want it to be negative y, we want it to be y, so if we divide everything by -1, that will fix that for us. However, we remember that anytime you multiply or divide by a negative, you have to flip that sign. So it goes from being greater than to being less than. -2x divided by -1 is a positive 2x, and -2 divided by -1 is positive 2. Now we're in slope-intercept form and we can graph. We have a y-intercept of 2 and a slope of positive 2. So we're going to rise 2 and run 1, rise 2, run 1. This time we have a less than. Is that solid or dashed? Because it's just less than, it's not equal to, it's going to be a dashed line. And then we need to determine where to shade. We can use 0, 0 again. So if I plug in 0, I get 0 is less than. 2 times 0 is just 0, plus 2 is 2. Is 0 less than 2? And that is a true statement, so we're going to shade where 0, 0 is. So that's down here. And then with a system of inequalities, you end up with an area called the solution area. Where your solutions overlap is your solution area. So this area up here would be our solution area. All of the ordered pairs in that section would work for both of the inequalities that we worked with. When you're graphing a system of equations, you only have one point, but with inequalities, you'll have an entire solution area.